Welcome to the channel Bharat's Pharmacy. In this PowerPoint video, I'm going to explain about the sterilization and the various terminologies associated with the sterilization unit in pharmaceutical microbiology. So, what do you mean by sterilization? Sterilization is the process where killing or removal of all microorganisms in a material or on the surface of an object. And in one word, what you can say, it is free from any forms of microbial life or it is free from viable microorganism. So this term killing is applicable in few methodology. Removal is applicable in case of filtration. When you go for the specific definition of a filtration method, so sterilization is the process of removal of all microorganisms. And in general, for all the methodology, in common we can write the sterilization is the process where it makes the material free from any forms of microbial life. A surface or an object is either sterile or it may not be sterile. But here we cannot say gradations, right? For example, 50% is sterile, 60% is sterile. Like that, there is no gradations is applicable in the sterilization. Only thing you can say a material is sterile or not sterile. Typically, the last things to die when one attempts sterilization, it is the highly heat resistant the endospores. So that is why if the material or the process it makes to kill endospores and that material or that process you can make the material into sterile one. So spores are highly resistant. What is the term? And the very closely related term is called disinfectant. Disinfectant, it is a chemical or it may be a physical agent that is applied to an inanimate objects to kill microbes to certain level where it won't cause any infection. And disinfection, it is the process. It means reducing the number of viable microorganisms present in the sample. So as a regulatory body, it states that any number of microorganisms is reduced to a particular level, it won't cause any infection. And remember, not all the disinfectants are capable of doing sterilization. But based on the disinfectant action, the disinfectants are classified into three categories like low level, moderate level, and high level disinfectant. High level disinfectants are equivalent to it kills all the 100% microorganism. So that is applicable for both disinfectant as well as it can be used for sterilization process. One example, it is ethylene oxide gas. What is antiseptic? The other closely related term in sterilization and disinfectant and antiseptic. Typically, an antiseptic, it is a chemical agent that is applied to the living tissue to kill microbes. And here the differences between disinfectant and antiseptics. So both are chemical which is used to kill germs. But generally, antiseptics are made with less concentrated, whereas disinfectants are made into more concentrated form. Because in the environmental situation, the bacteria or the microbes is available in the spore state. Whereas in the case of antiseptics, which is applied on the living tissue, always our body, it is maintaining 37 degrees Celsius an optimal temperature and the moist condition which is available in our own skin, it don't force the microorganism to go into the spore formation. So that is why when you wanted to apply in the living tissue or in our own body, we don't require much concentrated chemical. So you can take disinfectant and you can use it on our own body, but due to harsh or high concentration, it produces some necrotic tissue or it produces some toxicity or irritation. Whereas when you take antiseptic and you pour it on the environment, so due to the spores form, so this concentration, what it is available or what we have prepared in the less concentrated form, it won't act as or it won't act on the spores. So that is why antiseptic you cannot use it as a disinfectant, and disinfectant you cannot use it as an antiseptic. If you use antiseptic as a disinfectant, it won't be much effective. If you use disinfectant as an antiseptic, it will be toxic to the human. And sanitization, it is the other closely related term. That means it's a cleaning of pathogenic microorganism from public eating utensils or drinking water. This is one more very closely related terminology in the unit of sterilization. And the other closely related terms, it includes biocide or germicide. Sida, it's a term, it is killing. That means it kills microorganism. It includes either of bacteria or fungi. And fungicidal, it kills only on fungi, and virucidal, it inactivates or kills viruses. And bacteriostatic, it just stops the growth of bacteria. Whereas bactericidal, it kills the bacteria. Static is the one that just inhibits the growth of bacteria. So if there is a 5 cells, only that 5 cells it will be remain when you use as a bacteriostatic agent. Whereas bactericidal agent, when you use that 5, it may get reduced into 4, 3, 2, or 1. That depends on the concentration of the bactericidal action. And the other closely related terminologies in this sterilization unit, it is D value. That means it is the decimal reduction time. The time required to kill 90% of the population which is present in a particular sample. And the Z value, the increase in temperature which is required to reduce D value to 1 by 10th of its original value. And what is F value? The time in minutes at a specific temperature needed to kill a population of cells or spores. And now in this slide, I'm going to explain the various method of classification of sterilization. So most common examination question is that you can explain, define sterilization and classify various sterilization method. Explain any one sterilization method. That is what the most common questions may expect in the university examinations. And here in thermal method, that is divided into two types. One is moist heat and dry heat. Under moist heat, so you have various methodologies. The first one, it is boiling and heating along with sodium bicarbonate in pasteurization. So again, under pasteurization, we have methods. One, it is called Holder method. This is what originally devised by Louis Pasteur. And next to this process, now we are modified into a flash processor called as HTST, called high temperature short time, where we are using the temperature of 71.6 degrees Celsius in just for 15 seconds, whereas earlier it was there as 30 minutes. And the next method is sterilization. Otherwise, it is called as inspissation or fractional sterilization. The methodology I'll explain you in the upcoming slides. And the next method under heat, thermal method, it's called dry heat sterilization, where you can use sunlight. This was the first dry heat method, mainly for even drying clothes. We are using under sunlight. And next, it is flaming. So just exposing inoculating loops and inoculating wires on the Bunsen flame, and just passing through and waving. And main method of dry heat sterilization. And today, when you say dry heat sterilization, it is synonymous to a hot air oven. And next one is incinerator. Incinerator is mainly as a destructive method, whereas the remaining three methods are non-destructive method. And the non-thermal method, there are some products based on the pharmaceutical product. So this can be divided into thermolabile and thermostable. If the product is thermostable, and definitely you can choose moist heat as the first choice of method. And product is thermostable and moist sensitive, then you can go for dry heat sterilization. But if the product is thermolabile in nature, then we cannot go for either moist heat or dry heat. So in these cases, the non-thermal method, we can use it. So under non-thermal method, so we can use filtration method is the first choice, where you have large volumes of fluid, even it is thermostable, and the volume of fluid is too much or too more, the quantity is too much, then you can go for filtration method of sterilization. And second choice is radiation. Quite expensive, but still vaccine industry depends on this radiation method sterilization. Or of course, you can go for gaseous method of sterilization, in particular ethylene oxide. So in the upcoming slides or in the upcoming videos, I'm going to explain each and every method in detail. And otherwise, this sterilization method, it also classified as a physical method of sterilization or chemical method of sterilization. And even one time, there was a university examination question is called cold sterilization method. That means the method where we are not using any heat. And the other question, it was there as a mechanical method of sterilization, where there are some instruments we are using, and that is called as the mechanical method of sterilization. In particular, it is filtration method of sterilization. And of course, even you can use a biological method of sterilization, where we are using bacteriophages, but it is not widely used because bacteriophages are highly specific to a particular bacteria, a virus killing a specific bacteria. It won't be effective for every bacteria, so that's why it is not an effective method. But in vaccine industry, in few cases, this biological method of sterilization also we can adopt. So now the first one is moist heat sterilization, and this moist heat sterilization further is divided into two types. And temperature below 100 degrees Celsius, temperature at 100 degrees Celsius, and temperature above 100 degrees Celsius. So temperature below 100 degrees Celsius, the example is pasteurization of milk and inspisation. And temperature at 100 degrees Celsius is a simple boiling, and temperature above 100 degrees Celsius, autoclave or steam under pressure. So temperature below 100 degrees Celsius, the milk pasteurization of milk is the one best example. Initially, this Louis Pasteur was used to the procedure of 62.8 degrees Celsius for 30 minutes exposure, that it kills most of the pathogens or microorganisms which is spoiling the milk. But now, due to the 30 minutes duration, longer duration, this process we modified into 71.6 degrees Celsius for just exposure of 15 to 20 seconds. And that's why this process is called the flash process, or it is called as HTST. And now, even today, we have ultra short time methodology is also available, but mostly the industry today we are following this flash process for shorter duration. And after this exposure and sudden cooling, it makes the pathogenic or the organism which spoils the milk that is getting killed. And by this process, all non-sporing pathogens, it is mainly of Mycobacteria and Brucella and Salmonella, are destroyed. And inspisation is the one where the material is exposed into 80 to 85 degrees Celsius half an hour daily for 3 successive days. The mechanism behind this, the temperature of 80 to 85 degrees Celsius, the first day all the spores, the vegetative cells are getting killed, whereas the spores are thinking, we made to think the spores into the environment is favorable. So that is why the spores are started germinating in the second and third day. So this inspisation method, today we are using it for making the material, making the medium, especially a serum containing and egg containing medium. So we can't expose into high temperature. So these media, which is containing serum and egg, we are making into sterilized by using inspisation. And even vaccines at 60 degrees Celsius, when you feed it at several successive days, we can make sterile, and like maybe we can avoid a contamination of the other microbes. And in this inspisation, the steamer is specially designed with the tinned copper cabinet, and the lid is it is conical, so that it enabling the drainage of the condensed system on the sideways. It won't directly fall onto the material. A perforated tray is fitted above the water level. It ensures that the material placed on it and it is surrounded by the steam. So what is the principle behind in this inspisation is the first exposure, it kills all vegetative bacteria which is present in the sample, and later stages it is spores. So during the second and third day and the successive days, the spores are getting converted or it is germinated into other vegetative cells. And subsequent occasions when you start doing it, all the spores are getting converted into vegetative cells, and the exposing of 80 degrees Celsius that it kills all the vegetative form. And this method, it may fail the spores are certain anaerobes and thermophiles. And a single exposure of 70 minutes, usually it ensures the sterilization, but for media containing the sugars, especially saccharides or gelatin, an exposure of 100 degrees Celsius for 20 minutes on 3 successive days, we can achieve the sterilization. So this process is known as tinderalization or intermittent sterilization, or even you can call it as fractional sterilization. And temperature at 100 degrees Celsius is simple boiling, where vegetative bacteria is killed at of 100 degrees Celsius. We are even heating at 80 degrees Celsius that we can make it. But that is not effective for the spore forming bacteria. And the addition of 2% sodium bicarbonate, it just increases the sterilization efficiency and boiling. And temperature above 100 degrees Celsius, it is the best example. It is an autoclave. So the functioning of autoclave, the mechanism, principle, procedure, so that I will upload it in the next video. Thank you. Subscribe the channel for more updates in the unit sterilization. Thank you.